This is a short video tutorial on how to prepare a hydrological scenario in Ribosim 7. I will demonstrate the process on a ready case of the Virgin River Basin model. Opening this case in Ribosim brings you to the initial screen of the case management tool. As a reminder, hydrological scenarios are selected by clicking on the task block, Select Scenarios, Measures, and Strategies, and navigating through the combo box of available hydrological scenarios. Each available scenario is defined by a list of time series files, and the simplest method for preparing an additional hydrological scenario is to copy and modify the files of these existing scenarios. These files are stored in the .rbn directory of your model under the hydrolog subdirectory. First, make a copy of an existing scenario directory and rename your newly created directory. Make sure that you name it the word scenario followed by a dot and 3 characters. In my case, I will use 122. Within your new directory, you will find a number of files. First, open the directory information file with your preferred text editor and modify the first line. This will be the name of your scenario that will appear in the combo box for selection in Ribosim. I will name mine T12 New. Save this text file and close. Another file is the hydrological time series data file. Opening that, you will find a list of time series files used in this hydrological scenario. Ribosim uses 2 types of time series. The first, a long multi-year time series, and another, an annual time series. Each hydrological data is attached to a particular index, and the .tms files or the time series files are attached to these indices at the bottom of this file. The type and the number of hydrological time series relevant to your case will depend on your network schematization. For more information, refer to the user manual in Appendix F.2. Multi-year time series files are attached to a specific node type. It is important to ensure that these time series are empty if the node type does not exist in your model. This is important because Ribosim only runs through the period where the time series overlap, and removing unnecessary time series ensures that they do not influence the run period. In our case, for example, we do not have a general district node. Therefore, the district demand and discharge series must be empty. We can navigate to these files and delete all data within. Now let's move on to editing a time series. In this new scenario, we will change the inflow. Locate the actual inflow file and open to edit. The first line of this file specifies the format and should not be changed. The lines following are comments indicated by the asterisks at the beginning of the line. The comments are followed by 2 numbers. The first, number 7, indicating the number of series or stations in your time series file, and the second, number 1, indicating the unit of your values. The definitions of the units are described in the comments above. In this case, we use 1, which is cubic meters per second. Underneath these numbers are the series names, and finally the data. The numbering on top of each data series is how it is referred to later in Ribosim. To edit inflow, you may choose to overwrite existing time series or add additional time series in the file. In this case, we will add an 8th and 9th series. This is easily done through Excel. Open an empty workbook in Excel and navigate back to your actual inflow time series file. In the text import wizard, select Delimited and uncheck all the delimiter options. This preserves the format of the file. Now just selecting the rows with the data series, we can separate this by using the Text to Columns option under the Data tab. In this wizard, select Delimited and separate with space. Make sure that the numbering of the data series is in the correct location. If it is not, move it to the correct cells. We can then add additional columns for the 8th and 9th series. These new series will just be double of the series 1 and 2. Then we select all of our data in this Excel workbook, copy, and paste it back into our text editor. Finally, we must change the number of series in our file from 7 to 9 and add series names. Before saving, we must close our Excel workbook and then finally save our text file. Going back to the case management tool, our new scenario should now be visible in the combo box of available hydrological scenarios. Select this new scenario, click OK, and save under a new case name. Then move on to the Specify Simulation Control Data task block. Edit the Run Identification name and click OK. Once this block is green, you can right-click and open the log time series range. In this log file, you will find the list of time series read in and their period range. Notice that the district demand and district discharge time series are at -2 because these are now empty. At the bottom of this log file, you will find the longest simulation time series, which will be the run period of your RibaSim model. Any errors for reading in time series files are also found in this log file. To assign the new series to the nodes, we move on to the Edit Network and Database on Map. Edit Network and Object Data. Left-click on one of the nodes and right-click to access the model data. And under the Variable tab, you can edit the actual inflow time series index to our new series, which was 8 and 9. Click Apply, OK, and save your new network. Once this is green, you may run your river basin simulation. And finally, save the case. Using the case analysis tool of RibaSim, we can compare the base case and our newly created case with this new scenario. Comparing the inflows, we can find that the inflows of our new case are double of the original base case. This is the end of this tutorial for creating a hydrological scenario in RibaSim. Thank you for your attention. I hope it was useful.